Hello everyone. How are you guys doing today? Tired, me too. I'm so sleepy. True. Yesterday it was so sunny and everything. So warm. And at night, my 2 years old niece, she was saying, well, tomorrow it will rain. I was like, there's no way. Today it was so warm and hot. There's no way it will rain. She was saying, well, tomorrow it will rain and it will snow. Suddenly she was saying that. I was like, no way. And then when I woke up this morning, I was like, really? How did she know? She's only 2 years old. But wow, cool. What a coincidence. So yeah, see weather. There is no guarantee what weather we'll see every day. It's so weird. So we are going to learn some new rules. And these are your last set of exponent rules. So write them down, and then we are going to do many examples today. And you are going to work with your neighbors to do all these examples. I believe today we'll have a fun class because you're going to talk a lot with your neighbors. So on the left side, it's saying, well, if you have a fraction power, this is same as you have a radical. So a to the power 1 nth is same as nth root of the base a. The second one says, if you have a fraction power where you have both numbers on top and bottom, this is same as you have a to the power m and then the radical nth. So nth root of a to the power m. The left page and the first portion are the same. They just the left as an definition, and on the right I wrote them as exponent rules. They're same. And these are actually power, x to the power 1/2. So it's x to the power 1/2. This one is x to the power 1/3. This one is x to the power 1/n. All of these are exponents. Let me take the attendance since I will be writing. Today is 227. Brianna Almonte, not here yet. Christina, here. I was just calling your name. Catherine, Jolene, Govan, Madison Field, Eric, Abraham Sick, Stephanie here, Leandra here, Robert here, Katie here, Kimilcia out, Maria here, Sandy's here, Michaela here, Madison Orlando absent, Angie absent, Mazavin here, Melvelis, Giselle here, Mohammed here, Tahsin here, Gavin here, Brian at Texas here, Carla absent, Yvette here, Nick, Daniel here, and Hassan either late or absent. Okay, let me explain. The first one says square root of x is same as x to the power 1/2. The second one says, well, by following that, that means cubic root of x should be x to the power 1/3. And then in general, if we have any type of radical, it means x to the 1/, that thing. So if you observe, whatever we have inside the radical, that actually goes on the bottom. So square root, square means 2, so that's why you have 2 on the bottom on the power exponent. Cube root, so you have 3, so 3 goes on the bottom as power, fraction power. So whatever number you have inside your index, that is the denominator. So I actually forgot to tell you. So nth root of x. This nth is called index. And this one is called argument or base. It has two names, argument and base. And that is called index, or we call them root. So whatever index we have, that goes on the denominator. That's the rule. Now this one says, well, what if we have an index, also we have an exponent inside? So in that case, what happens is this, the exponent goes on the numerator, and in index, the root goes on the denominator. This one says, well, you can write root first and then power, or you can write power first and then the root. The order, usually most of the time, when your base is positive, when your argument is positive, they are same. That doesn't make any difference. But when your base is negative, then it makes a difference. Okay? So for positive argument, all three are same. But if your base is negative, then these are not same. But this is same. The second set is talking about negative exponent. We hate negative powers in our life. So anytime you have a negative exponent, turn into a fraction, it will become a positive exponent. So if you x to the -2, it's same as 1/x to the +2. So if you forget, what you're doing here is that below that we have 1. So in order to convert, we just switch our position. So x to the -1 goes on the bottom, it becomes positive, and 1 goes on the top. Same thing here, we had an invisible 1 below that. So to convert that into positive, we just switch the position. So x to the 2 goes on the top, becomes positive, and 1 goes on the up. Same thing here, any number, n means any number. So if you have any number, x to the any negative number, just switch the position and it will turn into a positive power. Similarly here, it doesn't matter what your power is. It can be fraction, it can be whole number, it could be anything. In order to get to the negative sign, all you have to do is put 1 over the exact same thing with positive sign. The last one says, well, what if you have a fraction of the negative power? It's same. You just switch your numerator and denominator, and the negative power will turn into a positive power. And then if you want, you can distribute the power, then you have y to the n over x to the n.
Every time it's negative, you always want to change it to positive. Like in any scenario.
Don't leave the negative power alone. So this is actually same as, let me write here. It says we have x to the negative n over y to the negative n, because we distribute the power. But we like none of them because they both have negative. So what we do, we put this on the bottom and we put this on the top, and they will turn into positive y to the n over x to the n, which is the exact same thing as this one. So that's why if you just switch your division, the power on the negative on the power turn into positive. Now, any question on any of the rules? No? Okay, so real life scenario. When you have square root of 4, this is same as 4 to the power 1/2. When you have cube root of 64, this is same as 64 to the power 1/3. When you have 4th root of 81, this is same as 81 to the power 1/4. They both are exact same thing. So this one and this one same, this one and this one same, this one and this one same. They both are same.
The denominator will always be the exponent.
No, denominator always be the root, the radical. Index. The root of the index. So here we have no number, but we know it's a square root. So we have 2 on the bottom. This one is a cube root, that means it's 1/2, 3 on the bottom. This is 4th root, it means 4 on the bottom, 1/4. So every index turns into the denominator. And now for square root, we are too used to seeing the square root, so we actually don't even need to turn square root into a fraction, because we can easily solve any type of square roots. So our answer is 2, because you're too used to seeing square root. When it comes to cube root, either you simplify as a cube root or you turn into 1/3 power. Whichever you are used to, stick with that. What I personally like is convert radical into exponents, because later we are not going to have 1 on the top, we are going to have different number on the top. So we want to keep our exponents and then simplify the base. So cube root means basically they are asking for find a number when you multiply the same number 3 times. The result is 64. This is what they are asking. Number multiplying 3 times give us 64. What that number is? 4. So you can directly write the answer is 4, because you already know cube root of 64 is 4. Or you can actually work this out. You rewrite your base by leaving your exponent alone. We need to write base in terms of the denominator, because that's the root. And we know 64 is 4 multiplying itself 3 times, the 4 cube. So you can write 64 as 4 cube, leaving 1/3 alone. And then something cool happens. The 3 power and 3 denominator, they cancel out. So we left with 4 from the inside. And outside we have 1. It's 1, so you don't have to write it, but again later it will not be 1. It will be a different number, so you must bring it down and then apply your power. So see, they are the same totals, same answer. So if you forget your answer, no problem. Just rewrite 64 as something to the denominator power and then cancel. Now fourth root. Fourth root is asking for what? Same number how many times? 4 times. So can you think of a number if you multiply the exact same things 4 times, the answer is 81. 3. So you can directly write your answer is 3 because 4 root of 81 is 3. Or if you don't remember, no problem. All you have to do is rewrite your base. Keep your exponent 1/4, but rewrite your 81. And we cannot use 9 squared because our denominator is a 4. So you're looking for same number 4 times. And we know 3 to the power 4 gives us 81. So it's 3 to the power 4. So whatever we have on the denominator, we have to rewrite our base with the exact same power. Why? What is our goal? To do what? Cancel the denominator. We hate denominators. Anytime we see denominator, we hate that. So we cancel, and now we love it. We have 3 from the inside and 1 from the outside, which is same as 3. For 1, it's not important. I'm showing you because later it's not the 1, to be different number. So we get confused, well, how this come down? So I'm starting your knowledge from bringing it down. Any other question? Go ahead.
You see how in B and C, the 3 and 4 will cancel out. Would that be in any scenario?
If you can find any number that many times. Like if the root exists. For example, cube root of 64 exists, so you can rewrite 64 as a 4 root cube. But you cannot find 4th root of 64.
So if that was to be like the answer, if that was to be the equation, what would I have to do?
You simplify. Just like square root of 8. Square root of 8, we don't know, right? But I do know square root of 8 has a 4 inside. So it's 4 times 2. So you break down square root of 4, square root of 2. Now this gives us 2, and that we have no idea. So when you don't have a perfect cube, perfect root number, you simplify if it's possible. If it's not possible, leave it alone. And say, well, without calculator, we don't know. So we learned how to convert radical to fraction and how to find numbers both under the radical or both when you have a fraction. Next, well, what if we have negative base or negative radicand? So you have two scenarios. If your base is a negative, okay, your base, not an extra negative sign. If your base is a negative, and how do I know a base is negative? Because we have parentheses around that. So if you have a negative base and you're trying to find any type of even root, for now it doesn't exist. For example, here it says negative 4 to the power 1/2. This is same as, let me actually move this inside page. So this, the first one is telling us you have Square root of -4. What does that mean? Find same number multiply twice becomes -4. 2 times 2 is 4. You can say -2. But -2 times -2 is +4. See? We can never multiply same number even times and it can turn into negative. In real life, it's not possible. So for this case, it doesn't exist in the real world. Square root of -4. But it does exist in the imaginary world. So math has two worlds, okay? We have only one world. Actually, no, we have two worlds. One is where we live, and one is inside our head, right? We imagine things. Same thing math. Math has two worlds. One is realistic world, and one is unrealistic world, which is imaginary world, a complex world. So in imaginary world, it does exist. But in real world, it doesn't exist. So later, we are going to learn more details about that, about imaginary number. But for now, just remember it doesn't exist. Okay? Same thing here. This one is telling you this is 4th root of -16. They're same. So they're telling us find one number, multiply the same number 1, 2, 3, 4 times. The result is -6. Can you find such number? You multiply 4 times, it becomes negative. Not possible. So the answer is doesn't exist. So if your denominator is even, it means you're dealing with even root. Even root cannot have any negative number inside. Even denominator cannot have any negative base. Here, even denominator base cannot be negative. However, for odd, it doesn't matter. Odd number can have positive number, negative number, anything. For odd, they have no problem. They're odd. They're weird. They have no, what is called? They have no, I forgot the word. Here's a nice word. Demand. They have no demand, not even demand. There's something cool word. But anyway, so they have no problem with anything, okay? You can have positive number, you can have negative number, you can have extra negative, you can have anything. You'll always have some answer, always. So events are more strict. They cannot have answer for everything. They have a strict policy, their base have to be, all the bases have to be positive. So, I told you before, eventually you'll see a number bigger than 1, like 1 on the top. This is a scenario. So the first one is saying that, well, we have 64 to the power 2/3. Now 2/3, we look at the 3 only. The 3 is telling us how to rewrite the 64. How do you want to rewrite 64? As a 2 power or as a 3 power? 3 power, because our denominator is 3, we want to cancel that. So which number, if you multiply 3 times, turn into 64? 4, we already did that. So you rewrite 64 as a 4 cube. The 3 power, 3 denominator cancel out. We have 4 inside, but this time, what power we have left with? 2. So we have 4 twice. What's the answer? 4 square is 16. See? Bring the power, whatever is left, bring it down. And after cancellation, bring your base down. And then apply your power. What is happening in the next one? It's negative. So is our base negative or this negative is extra? What's the difference between?
This negative is extra.
Good. The difference between these two is that our base is negative here because of the parentheses. But no parentheses means extra. It's just like a multiplication. It's negative times your 64 to the 2/3 power. So you rewrite your 64 just like this one. We want 4 cubes so we can cancel the 3. So we have 4 cubed, they cancel out. We still have our extra negative 4 from the inside, 2 from the outside. What is our answer? Positive or negative? Why positive? What is your base? Negative 4 square or only 4 square? Negative. Say clearly, show you the multiplication. Usually you don't see the multiplication. But see, if you think of it as a multiplication, you can see this is just coming down. Because Pamela says, do the power first, and then the multiplication. Oh, why am I 16? I suppose it's 16, not 4 square. So the second one is actually giving us negative 16. No, it's negative 16 without any. Or 3? What is the denominator? Add or even? Add. So that means we are. They have no problem. They have no problem. They have no ego. They have nothing. They're odd. They're weird. So weird can take everything. For example, you can say weird stuff to weird people. They don't mind, right? But if you say weird stuff to normal people, they will fight you. Like, why are you calling me this, calling me that? They fight. But weird people are like, ah. So anytime you have an odd, something exists. It's real. But if you have even, it doesn't exist. Add denominator. Always give you some answer. But if you have even denominator with a negative base, it doesn't exist.
So it has to always be odd.
No, it depends. The thing is, if you have a negative base, can you find a number that you multiply 3 times and you get negative of that number? In here, can you think of a number, multiply the same number 3 times, turn into negative 64? Really?
But if you think about it, it's gonna be positive no matter what. So don't you have to be the same?
If you multiply negative 3 times, what it becomes?
You're right.
See? That's why negative base doesn't care if the power is odd, if the denominator is odd. Because you can have the same odd, same negative number add many times. It's possible. So we rewrite which number, if you multiply 3 times, turn into negative 64? Negative 4. So it's negative 4 to the power 3. Negative 4 times negative 4 is positive 16. Positive 16 times negative 4 is negative 64. Same thing happens. 3 cancel out. But our base is negative 4. So you must bring your parentheses down with your base because you have a power outside that you have to apply. So what's the answer this time? 16. So for add root, there is no problem. It always has some answer, always. But we couldn't have any answer for the even root with negative denominator. Sorry, even denominator with negative base. Any question? If you don't remember all the rules, no problem. Ask yourself like the way I did. Can you multiply the same number 4 times, turn into negative 64? If you can find an answer, write it down. If you cannot find, that means the answer doesn't exist.
That's all. The one is basically.
No, if one is on the numerator, it's always visible. When you bring it down, it can make it invisible. But the idea here, it's a fraction, right? So they're asking for, can you find same number twice and the result is -4? On the right side, it says, can you find one number multiplied 3 times becomes 64? So same number 1, 2, 3 turn into 64. And we found that it's 4. 4 if you multiply 3 times turn into 64. They are asking, can you find one number when you multiply 3 times? 1, 2, 3 turn into -64. And you're so smart, you said, well, it's -4. Because we have 2 on the top, not 1 anymore. If it's 1, you leave it alone. But if it's not 1, you have to apply that.
So, is it safe to say that positive things or negative things with the positives?
Always have an answer. Always. Now, what's the difference between -9 with that and -9 with that? Are the same. Mhm.
The negative sign, one is inside the parentheses, and one is being multiplied to the one that's not parentheses.
So which one has an answer? The negative without the parentheses or negative inside the parentheses? Without the parentheses. So this one extras you're multiplying, and 1/2 means square root, right? Square root. So if you want, you can rewrite a square root. It will help your brain to work faster. What is square root of 9? 3. So negative times 3, the answer is -3. On the other hand, if you rewrite the other one, it's square root of -9. And if it's in negative inside the square root, your brain automatically tell you, hey, it doesn't exist. Because you cannot multiply same number twice and it becomes negative. So this one doesn't exist. For now, okay? But eventually when you talk about imaginary number, it cannot write DNA anymore. Medicine.
So the first one answers this because the negative is not.
Right.
And then the second one.
The base is a negative.
Right.
So negative base, even denominator, cannot possible. Even denominator means multiply same thing twice, turn into negative. Can you ever do that? That's why it doesn't exist.
So every time you see a scenario where there's a negative in the parentheses, it doesn't.
No, it denominator on the power, if it's
So
even.
-9 in the parentheses, and it will be 1/3. Yeah.
It can exist. We just don't know how much is it, but it does exist. Okay, now how about this one and this one? Which one exists? Which one doesn't exist? Or both doesn't exist? Or both exist? What do you think? Catherine? Why not? Exactly. This one doesn't exist because they're asking to find same number 4 times and gives you -81. 1, 2, 3, 4 cannot be negative. It always has to be positive. Whether you take a positive number or negative number doesn't matter. If you multiply 4 times, then it has to be positive. But look at here. It's negative. So what will be the answer for the first one then? This negative is extra, and you have 1/4 power. You're looking for same number 4 times, gives you 81. So 3 to the power 4. If you don't know this, you have to multiply manually to figure them out. But the best thing is just remember them. We are going to use 64, 81, 27, a lot in this class. Hey, welcome back. How are you feeling today?
Better.
Good, good. So we have 4th root, 4th power cancel out. We have negative extra, 3 from the inside, 1 from the power, which you don't have to write here. So answer is -3. Cool. They both give me negative answer, -3. Any question? So let's do one example with negative power. Before you do that, let me do one example. One more example. Let's say you have 4 to the -1/2. Oh, before even 1/2, let me start with easy something. 4 to the -2. Do you like negative power? No. So we can convert this into positive power. How?
4/1/2. No, 4. Okay, I give up.
Close.
4/2/1.
No. You're converting the wrong one. This is not square root of 4. Square root has to be 1/2 power. But I didn't give you 1/2, I gave you -2. Giselle? 4 to the 1/2. 1/2 over 4. 1/2. 1/2 over 4, no. It's too many? No. 2 over 1, no. Below that, we have invisible 1, right? So how do you convert negative into positive?
1/4
See? That's the correct answer. You just have to bring this down. So it becomes 1 on the top, 4 square on the bottom. And what is 4 square? 16. So it's 1 over 16. So if you don't remember, do like me. Put it over 1 and then just bring it down. Okay, one more. -1/2. Now what happens? Huh? We cannot square. In order to square, we have to have one side equals another side. Put it over 1. So 1 over what? Huh? 4 to the power 1/2. But what is 1/2 means? 1/2 power means square root, right? So this is same as you have 1 over square root of 4. And what is square root of 4? 2. So it's actually 1/2. A fancy way they are saying 1/2, that is 4 to the -1/2 power. Confused?
Yes.
Which part?
I'm confused about how you use this.
Anytime you have 1/2, convert into square root. Only 1/2, okay? Nothing else. Convert to 1/2. Why? Because our brain is too used to looking at square root symbol. We don't see cube root much, right? Or fourth root or fifth root. We don't see them much. So when you have 1/3, 1/4, 1/5, leave them alone. But whenever you see 1/2, then oh, 1/2 is square root. So convert to square root. You can see the answer easily.
That's only if it's a negative number.
It doesn't matter, negative or positive. Anytime you have power 1/2, rewrite it as square root.
Okay. So if you have like 4, then it's like
Cube root, yes, you can do that. You just don't know how much that is.
and but would that be the answer?
Oh. But in this class, everything we give you, there will be an answer for you to find. You don't need a calculator. For example, next one. Before you do that, let me give you a few more. Let's say you have 16 this time. So let me give you 2 of them. 16 to the 1/2 and 16 to the negative 3/4. Do you think are they going to give us the same result or different number? Obviously, because our roots and powers are different. So the first one, 16 to the 1/2. Anytime you see 1/2, you already know, right? 1/2 means what is given to you? Square root. Now the only problem is negative. How can you rewrite your negative with a positive 1/2 power? Flip. So we have 1 below that. Flip it, it will become 1 over positive 16 to the 1/2. And now you know 16 to the 1/2 is same as square root of 16. What is square root of 16? 4. So what is our answer? 1 over 4. But the next one doesn't have any square root. For negative, yes. Negative power means a fraction. Now for the next one, we don't have a square root, so don't convert. Instead, rewrite your base. So here we do like 2 things. 1, the negative, and 1, the denominator. So it's up to you which one you want to get rid of first, the negative or the denominator. Negative? Okay. If you get rid of the negative, that means you're working with a fraction. So below that, you have invisible 1. So bring it down. It will become 16 to the 3/4 and 1 on the top. So one problem is solved, no more negative. And now comes the second problem, 4. How do we get rid of this 4? What can we do so that the 4 will get cancelled out? We rewrite 16. 16 is 2 to the power 4. If you multiply 2 4 times, it will become 16. And now you're very happy. Our denominators also cancel out. Now a denominator. Cool, right? So now what do we have? 1 on the top. And what is 2 to the 3rd power? 8. So we have 1 over 8.
So you're able to convert it into this, okay? Like you see how you did 16 and it wouldn't be.
You could do the exact same thing here, But I didn't because square root, you already know. We're too familiar with the square root symbol.
Which questions will it come next?
For exponent rules, you have 35 points, 35 questions. The rules I gave you today and the rules I gave you at the beginning.
There's more rules on this?
No, this is the last rule we have. Last exponent rules. Next week, Friday. Any other question? Then you have a bunch to do. Do all of them together and you'll be done for today. Yep, that's all for today. That's what I said. You're going to have a fun class because you're going to work with the neighbors. You don't have to work alone. Talk with your neighbor. If you want, you can move around with your chairs. You know, more brains work faster than one brain. As long as those brains are working, not gossiping. Move around. If you did not give me a reflection, is there anybody who did not give me a reflection yet?
Damn, I really am playing.
Maybe tomorrow. You didn't give me a reflection? And the
No, I'm really playing, like I don't remember.
okay, so who needs
We gotta try to go to school, right?
Say, like, speed.
Oh, I'm taking the break. Thank you.
Did I do?
No, but I don't know. I don't know, like everything is left my brain. Can I ask you a question?
For bigger numbers, you multiply starting from 2. What is 2 to the 5? What is 3 to the 5? What is 4 to the 5?
Am I doing this so far? And then I would just go with it.
No, just you said I got.
Okay, so basically what I do, which is I just literally like 2 to the second power square. And then I just.
What's the difference between this one?
Yeah. Okay.
They definitely are not same, right?
Why do you?
Why does
No, you see how like this is already the base is 3 over 2, right?
Why do you
And think about it, 3 to the second power is already 4. So like, just think about 2 times 2.
So I just try to like substitute it, they kind each other out until you. That's pretty important.
Yeah.
So if you don't remember the rules, no problem. Ask yourself, if choose technically to be like 4 with some number to the 2 power. Can you write 4 as something to the power? 0 to the power. Now for this one, can you write -4 with some number to the square power? Now,
I used to do it. I don't think it's
Choose
over
square,
in my head.
exactly. Then you choose square. Can you find the number of it?
So when the exponent with the negative is not the parentheses, that means you're not multiplying. Right? It's a parentheses. Okay, I'm gonna try to redo it.
I didn't think you. Then why can't you? On the last one, all of us here. How do you?
That is. I get it. This is the same thing as
You
or you.
think number one.
Kind of sure is like you need to do it like that. Just to like see you will get that.
These are the powers coming out. You remember how to do it. Because negative 2 square is conjugate. 2 square is conjugate. Like nobody can make negative 2. Like there's already two people.
You know, then.
Oh.
Yeah, I got
Over the. Oh, why is it?
I never got to. Wait, what was it? Wait, I didn't get to it. I got to. So basically what I did was went to the second power. Okay, 2 to the second power is 4. So basically I just try to like solve for an exponent for 4. So whatever, like I'm trying to figure out what we get towards x right out the denominator. So what I found out the second power is 4. No, I think it was like I don't know when it's weird. I can tell it's gonna be better. So 4 to the second, 4 whatever. What do you multiply twice that gets you this? So let's do 4 to the second power. And we're gonna put the same bracket outside. There's an exponent of 4 with another. So obviously, bring this down to 4 to 30. I'm bugging. It's supposed to be 2. You know what I do? 2 to the second power. 2 times 2 times 2. You still don't get it. I mean, like I get it, kind of, but you're not like really sure, like your words are made. This kind of sounded like that. Okay, so for this one, it would be 3 times 2. You just and then they cancel out.
Oh, yeah,
And this one is 2 to the third. It's like, Wait, where'd you get negative 8? Is this, oh, this is the second one, I haven't used that one, you're right. But if you did the first one, you can like, they would get. I don't know. I don't know. And the third one is not exact. Yeah, I mean the same for the negative. Well, no, because when the negative is like that, it's not minus negative sign. So when it's in the parentheses,
Oh, yeah.
but I thought in the parentheses, you're multiplying it all together, and that's why they're not.
You always.
Okay, I don't know where.
So.
Wait, but when is this not exist? So for negative eight, you can even root.
100,000.
So-
You're going to have an even number.
So this wouldn't, this doesn't exist, because this is an even base, and there's an even root.
Is it 3 or 5? Even number multiply 2, they're even roots. You multiply, so that's going to say
Oh, no.
no.
Oh my God, this is actually hard. I think yeah. Too much to memorize.
Now what is 1 to the any? That's why it's going to be 1 to the any power. 1. So see this. 1 over.
You know, we just numbers like this. I don't understand why we
Four, nine.
like it's just a little more easier.
That's 64.
No, like this one is I didn't even come up with your.
What do you have? 4. 0. Then we have. Those
Fingers is much more. I really so understand. I'm gonna try to do it with the way that it's
Right now, it's together.
It's in the wrong one. I think this is.
Yeah, to structure your find those for you. So you can add them while you start multiplying it. What is 3 to the 5? What is 3 to the 5? 5 to the 5. The 5 to the 5 doesn't even make 7 to the 5. It multiplies. But in this class, I'm sure those whatever you
I remember taking this last.
Are you guys having fun?
No.
So 1 over 60 that gives you. Oh, so like Q 1 is perfect. And this is 4 square.
number C.
1 over
Why did I take a
What would be to 1 over? Always be 1 over 1 over. The next one is. And then next one is, what happened to your negative sum? Your base is negative, right? But you keep your base negative. And then you find the numbers. You're looking for the negative power, not negative base. You keep your negative base inside the runner. Oh, what? See, now you have negative 4 inside the line, this is square, right? So, but it is negative 4 cube, right? They're doing everything. So this is what are negative 45, it's gonna negative 64, 4, and then outside you have hello, this is the one of us, we have negative 4 inside the parentheses. Are you doing it how I'm not actually
The first piece,
it is negative
243.
But it's square.
I did it, but I can't find it. Okay. It's hard. 81. No, I haven't even tried it.
Yes.
Yeah.
It is possible. You're looking for same number 4 times.
That's right.
We're not leaving here.
Moving on.
You will, because all of these are finalized options.
Yeah,
They give you the finalized, I've turned into the finalized.
I just don't know how to start this one off.
You're basing an odd number. That means you're looking for an odd number to the high power. So it has more than odd number. After 1. 3. The multiple 3 manual one.
I do have a question how to do
Yes, one of this.
I go for the first one, I got 8, but that's how I do it.
No power.
But would that work for everything?
It depends. If you understand it very well, if you did, then if you don't understand it very well, then not everyone.
Because I also tried doing it this way and it makes a little bit of sense. But this will make sense.
Whatever is better for the whole house. I used to like this, but I didn't realize so. Without doing this, I'm like, oh, it is much easier to remember. I understand.
I feel like for big numbers like this, this way is easier, yeah.
Why okay, now let's do it together. Since we don't have much time. These are actually not bad. You just need practice. That's the main thing. You need practice. So make sure you do the homework. 10.2. So for next class, for next Tuesday, you have chapter 5 homework and section 10.2. Okay, so the first one. Tell me what to write.
So I put, since it's 4, 3 to the second, I put 2 to the second power. For right
2 to the second.
And then I cancel out the 2, which is brings down 2 to the third power, which is 8.
Perfect. That's it. The next one, it's negative times the first one. So 2 square, 2 to cancel out. We have negative 2 cube, which is negative 8. Now the next one is saying find same number twice. The answer is negative 4. We cannot do that. It doesn't exist. Now 243. 3 is an odd number. That means 243 is an odd number. So for this scenario, all you have to do is figure out which odd number into 243. You start by 3, always. Start with the smallest number. So we have 4. To some number to the 5 power. 3. It's 3 to the 5. And in this class, all the answer will be below 7, okay? Whatever you have, the answer will be below 7. If the power is higher, like cube or 4 or 5, the answer is below 7. So we left with 3 from the base and 4 from the power. And now 3 to the 4 means 3 multiplied 4 times. 3 times 3 times 3 times 3. 81. The next one is interesting. We apply the power rule fast, just like x over y to the power m. Remember the rule, x to the n over y to the n. Does this ring any bell in your head? So anytime you have a fraction on the base, distribute your power. So 1 to the 3/4 power and 256 to the 3/4 power. And then another rule. What is 1 to the any power? Positive, negative, zero, decimal fraction, anything. What is 1 to the any power? 1. How could you forget the generosity of 1? 1 is the most generous number. It doesn't give us any problem. It's always 1. So a numerator is 1, and denominator, we want to write the same number 4 times. Which number multiplied 4 times give you 256? 4. So they cancel out. We have 1 over 4 cube, which is 1 over 64. Try doing by yourself and then check the answers. Okay, the next ones. Can I flip my page? Okay, so 16 to the negative 3/4. If you want to get rid of the negative problem fast, so we have 1, you turn it into a fraction. 16 to the positive 3/4. And we cannot use 4 square here because you're looking for same number 4 times. So 4 square doesn't make sense. Instead, we rewrite as 2 to the 4, 3 to the 4th power. So they cancel out. We have 1 over 2 cubed, which is 1 over 8. Now let me show you the second method. What if you get rid of your denominator first? You're allowed to do so. That means you're going to rewrite your base in terms of 2. Now we can use 4 square because our denominator is 2. 2 to cancel out. We have 4 to the negative 3. So it becomes 1 over 4 to the positive 3. Which is 1 over 64. So I'm showing you both methods. You can get rid of the negative fast, turn into fraction, or you can get rid of the denominator fast by rewriting your base and then get rid of the negative.
So it's only clear when there's a negative inside the parentheses.
And your power is
And power
even.
Okay, so if it's a positive, it's still even in the outside.
It doesn't problem. It doesn't
Then
even
it will
problem.
still be.
So double negative. For double negative, our base is 3, so you're multiplying same number 3 times, turn into negative 64. Can you think of a number, multiply same number 3 times, become negative 64? Negative 4. So negative 4 times 3, sorry, negative 4 to the power 3 gives you negative 64. 3 cancel out. Now you have negative 4 to the negative 2. Now we don't want this negative power. The base is okay. But the power negative, we can get rid of that. Because we have 1 below that, so bring it down. We have 1 over negative 4 to the positive 2. Negative 4 square, it's square this time. It means negative 4 times negative 4. What do you get? 16. So this is what you do if you get rid of the denominator first. But let's say second method. You want to get rid of the negative first on the power. So negative 64 to the negative 2/3. Below that we have 1. Bring this down, it will turn into 1 over negative 64 with the positive 2/3 power. And in the same question, but 2 different ways. So 1 over, we rewrite this as negative 4 cubed. And we still have 2/3, they cancel out. So 1 over negative 4 square, which is same as 1 over 16. So it doesn't matter which method you use, the results are supposed to be same. 243, since it's 5, so you're looking for same number 5 times. Odd number. So 3 to the 5. Negative 4/5, 5 cancel out. We have 3 to the negative 4.
That's the fraction.
Fraction 1 over 3 to the positive 4. And if you multiply 3 4 times, 81.
So you see when you flip it, like you see how it's like you see how D is negative 4. The base would like negative, it would stay negative. It's only the exponent.
We can never change negative from the base. We can only change negative from the power.
The whole thing.
So here we have 246. So it's an even number and we're looking for the same number 4 times. So you do 2, it's 16. Then you do 4, yeah, 4 works. If you multiply 4 times, it will become 256. So they cancel out. We have 4 with the negative 3. We don't like the negative power, so we bring it down and the negative 3 turn into positive 3. Which is 64. 1 over 64. And yeah, with this we're done. So in our next class, we are going to do some exponent rules when multiplying. And then more example, fun example, but no more fraction power. So see you guys all. I already posted the review sheet on Brightspace. I posted it long ago.
Yeah, but I couldn't read it. I couldn't find it. It says exam 2.
It's under exam reviews. On the left panel is exam reviews. You go on the exam review and then you'll see.
Oh.
If you don't see, that means probably I forgot. Okay, I already posted.